Welcome back to Click Future, where your future is a click away. Today we're diving into a quantum revolution that's transforming how we make everything from computer chips to spacecraft. Quantum-enhanced manufacturing systems that can create materials and products that were previously impossible to produce. We're not talking about incremental improvements in manufacturing efficiency. We're talking about quantum computers designing and producing materials with properties that seem to violate the laws of physics. Quantum manufacturing is enabling the creation of metamaterials that can bend light in impossible ways, superconductors that work at room temperature, and ultra-strong materials that are lighter than air but stronger than diamond. These quantum-designed materials are revolutionizing industries from electronics and aerospace to medicine and energy. The implications extend far beyond just better products. Quantum manufacturing is enabling mass customization at the molecular level, where every product can be optimized for its specific application. We're approaching a future where manufacturing is limited only by our imagination, not by the constraints of traditional materials and production methods. Neil deGrasse Tyson has observed that quantum manufacturing represents the convergence of information science and materials science. We're using quantum computers to design materials atom by atom, creating substances with properties that nature never evolved and traditional manufacturing could never achieve. Today, we'll explore how quantum computers are revolutionizing materials design, enabling impossible manufacturing processes, creating products with superhuman capabilities, and transforming entire industries through quantum-enhanced production. Traditional manufacturing has always been limited by the properties of available materials and the constraints of production processes. We've been essentially rearranging existing materials in different configurations, but we've been unable to fundamentally alter the properties of matter itself at the atomic level. Classical materials science relies on trial and error experimentation to discover new materials with desired properties. This process can take decades and often fails to find optimal solutions because the space of possible material configurations is too vast for systematic exploration using traditional methods. Current manufacturing processes are also limited by the precision with which we can control material properties. Even the most advanced manufacturing techniques can only achieve limited control over atomic scale structures, resulting in materials with properties that fall short of theoretical limits. Charles Liu, the astrophysicist, has explained that traditional manufacturing is like trying to build a skyscraper with Lego blocks. You're limited by the properties of your building materials and the ways you can connect them. Quantum manufacturing is like having programmable matter that can be configured into any structure with any properties you can imagine. The economic implications of these limitations are enormous. Industries from aerospace to electronics are constrained by material properties that prevent the development of more efficient, lighter, stronger, or more capable products. These constraints translate into higher cost, reduced performance, and limited innovation. Energy efficiency in manufacturing is also limited by traditional processes that require high temperatures, pressures, and chemical treatments. These energy-intensive processes contribute significantly to global carbon emissions and make sustainable manufacturing challenging. But quantum manufacturing is fundamentally changing this paradigm by enabling precise control over matter at the atomic level, creating materials with properties that can be designed rather than discovered, and enabling production processes that are more efficient and sustainable than anything previously possible. Quantum computers can design materials with unprecedented precision by modeling the quantum mechanical interactions between atoms and molecules that determine material properties. This enables the creation of materials with properties that are optimized for specific applications rather than limited by what nature happens to provide. The breakthrough comes from quantum algorithms that can simulate the electronic structure of materials directly, predicting how atoms will bond and how electrons will behave in different material configurations. This quantum simulation capability allows materials scientists to explore millions of potential material designs computationally before building anything physically. Brian Greene, the theoretical physicist, has described quantum materials design as using quantum computers to explore the space of all possible materials, finding configurations that classical physics could predict but classical computers could never discover. We're not just making better materials, we're making materials that redefine what's possible. Quantum-designed metamaterials are showing properties that seem to violate classical physics. These materials can have negative refractive indices, making them invisible to certain wavelengths of light, or negative thermal expansion, causing them to shrink when heated. Such properties enable applications like perfect lenses and cloaking devices. Superconducting materials designed by quantum computers are achieving zero electrical resistance at increasingly higher temperatures. Room temperature superconductors designed through quantum optimization could revolutionize power transmission, magnetic levitation, and quantum computing itself. Ultra-strong materials with strength-to-weight ratios that exceed any natural material are being designed through quantum optimization of molecular structures. These materials could enable spacecraft that are orders of magnitude lighter while being stronger and more durable than current designs. Smart materials that can change their properties in response to environmental conditions are being designed with quantum precision. These materials can alter their shape, stiffness, conductivity, or other properties on command, enabling adaptive structures and self-healing materials. Quantum manufacturing is enabling production processes that operate at the atomic level with unprecedented precision and efficiency. These quantum-enhanced manufacturing systems can assemble products atom by atom, creating perfect structures with no defects or waste. Molecular manufacturing systems guided by quantum computers can build complex products from the bottom up, assembling individual atoms and molecules into precisely designed structures. This enables the creation of products with internal structures that are impossible to achieve through traditional manufacturing methods. Additive manufacturing, or 3D printing, is being revolutionized by quantum optimization algorithms that can design support structures, optimize material usage, and control the printing process with molecular precision. Quantum-enhanced 3D printers can create objects with internal structures that are impossible to machine or mold. Elon Musk has noted that quantum manufacturing is like having molecular-scale robots that can build anything you can design. Tesla and SpaceX are using quantum-designed materials and manufacturing processes to create vehicles and spacecraft with capabilities that were impossible just years ago. Semiconductor manufacturing is being transformed by quantum process optimization that can control placement of individual atoms in computer chips. This enables the creation of quantum processors and classical chips with performance that exceeds fundamental limits of traditional semiconductor manufacturing. Pharmaceutical manufacturing is benefiting from quantum-designed drug synthesis processes that can create complex molecules with perfect precision. These processes can produce drugs with fewer side effects and higher efficacy while reducing manufacturing costs and environmental impact. Aerospace manufacturing is using quantum-optimized processes to create components with internal structures that provide maximum strength while minimizing weight. These quantum-manufactured components are enabling aircraft and spacecraft with performance characteristics that were previously impossible. Quantum manufacturing is creating materials with properties that seem impossible according to classical understanding, but are achievable through quantum design principles. These materials are enabling applications that were confined to science fiction just years ago. Programmable matter that can change its shape, properties, and function on command is being developed through quantum materials design. This programmable matter could enable everything from self-assembling buildings to adaptive medical implants that change their properties based on patient needs. Quantum-designed optical materials can manipulate light in ways that enable perfect lenses, invisible cloaking devices, and optical computers that process information at the speed of light. These materials are revolutionizing telecommunications, computing, and defense applications. Self-healing materials that can repair damage automatically are being created through quantum optimization of molecular structures. These materials contain embedded repair mechanisms that activate when damage is detected, potentially creating infrastructure and products that last indefinitely. Jana Levin, the cosmologist, has observed that quantum manufactured materials are like having access to a periodic table of elements that doesn't exist in nature. We're creating substances with properties that evolution never discovered and physics never required, opening possibilities that transcend natural limitations. Energy storage materials designed through quantum optimization are achieving energy densities that approach theoretical limits. These quantum-designed batteries and supercapacitors could enable electric vehicles with 1,000-mile ranges and renewable energy storage systems that make fossil fuels obsolete. Biocompatible materials designed at the quantum level are enabling medical implants and devices that integrate seamlessly with human biology. These materials can promote healing, resist infection, and adapt to changing physiological conditions. Environmental remediation materials designed through quantum optimization can capture pollutants, break down toxic substances, and restore damaged ecosystems with unprecedented efficiency. These materials could enable large-scale environmental restoration and pollution prevention. The quantum manufacturing revolution is transforming entire industries by enabling products and capabilities that were previously impossible. This transformation is creating new markets, disrupting existing industries, and fundamentally changing how we think about production and consumption. The automotive industry is being revolutionized by quantum-designed materials that enable vehicles with unprecedented efficiency, safety, and performance. Electric vehicles with quantum-manufactured batteries and lightweight structures are achieving ranges and capabilities that make internal combustion engines obsolete. The construction industry is adopting quantum-manufactured materials that enable buildings with adaptive properties, self-healing capabilities, and energy regeneration integrated into their structure. These quantum-enhanced buildings can respond to environmental conditions and maintain themselves automatically. The electronics industry is using quantum manufacturing to create devices with capabilities that transcend current technological limits. Quantum manufactured processors, sensors, and displays are enabling new forms of computing, communication, and human-machine interaction. Investment opportunities in quantum manufacturing are enormous and growing rapidly. Companies developing quantum materials design software, quantum-enhanced manufacturing equipment, and quantum-designed products are attracting billions in investment from industries seeking competitive advantages. For consumers, quantum manufacturing means access to products with capabilities that seem magical, materials that are stronger than steel but lighter than plastic, electronics that adapt to user needs, and products that repair themselves when damaged. The quantum manufacturing revolution is bringing science fiction into everyday reality. The quantum manufacturing revolution represents more than just better production methods. It's a foundation for a new era of human capability where the physical world becomes as programmable as software. We're approaching a future where the only limits on what we can create are the limits of our imagination. Thank you for joining us on Click Future, where your future is a click away. Next week, we'll explore how quantum computers are revolutionizing medicine and healthcare, enabling treatments and cures that were previously impossible. The quantum revolution is transforming how we understand and treat human disease. What are your thoughts on quantum manufacturing? Are you excited about the potential for impossible materials? Let me know in the comments below, and don't forget to subscribe for more insights into the quantum technologies that are reshaping our physical world.